Alright, so now let's talk about the energy changes that go with nuclear reactions. So when there are nuclear reactions, there are corresponding energy changes. Now, these energy changes associated with nuclear reactions can be considered with the aid of Einstein's celebrated equation relating mass and energy, and we usually know this nga E equals mc squared. But we're going to put the symbol delta, which means change, because when there are nuclear reactions, there are changes in the mass, and these changes in the mass correspond to a change in energy. So later on, we will learn nga no day na siya. So, kani nga mass nga gi-refer diri is the change in the mass of the nucleus, of the nuclide. Okay? So, mass, which we're going to use the SI unit, so it must be in kilograms. And then for energy, that we're going to use joules. And C here is a constant, and that is the speed of light. And we're going to use the rounded off value nga 3 times 10 to the power of 8 meters per second. This equation can be used to find the amount of energy that results when matter is converted to energy. Meaning, inig na ay nuclear reaction na ay change sa mass, ang kadtong mass kay ma-convert siya into energy. Okay? So, muna siya gamiton. So, this is the table of nuclear masses. So, we have here the symbols of the different elements, their corresponding atomic number, the mass number, and if you notice, nga sa kada element, there could be more than one same atomic number but different nga mass numbers, meaning isotopes na sila. Nya, kanidiri nga masses, muna siya ang mga nuclear masses. Okay? So, here is an example of finding the energy associated in a nuclear reaction. So, we are to find the change in energy accompanying the alpha decay of 10.2 grams of radium-226. So, wala siya. This is not actually given, pero ang gibuhat diri is, ang step number 1 is to write the equation and predict kung unsay daughter nga nucleus. So, radium-226, so 226 is the mass number. So, ang inyong buong nabuhaton is pangitaon kung pila atomic number ni radium. So, and that would be 88. And then, mo undergo man siya alpha particle. So, 226 minus 4. So, the mass number of the daughter nucleus is 222. And 88 minus 2. So, the atomic number of the daughter nucleus is 86. Nya, mangita din sa periodic table, pila, unsa man ang atomic number nga, unsa man ang element nga na atomic number nga 86. And that is radium di. So, this is the equation. So, muna siya step number 1. Now, anong kinahanglan man na isuwat ang equation? Because we're going to use that to find the change in mass. So, ang sunod buhaton is tan-aw sa table of nuclear masses and look for the mass ani nilang tulo. So, si radium, 88,226, ato tan-awon. So, kani siya. Og si radon. So, this. So, 2259771. So, it's here, 2259771 AMU. Og si radon nga 221.9703. So, here. And then, for helium, tan-awon diri helium-24. So, it's here. So, it's 4.0015. So, here. So, sunod ana niya, nanan man kay masas niya, mangita ta, diba? This is 1 mole, 1 mole, 1 mole, diba? Muna yung mga coefficient diha. 1 mole of radium nuclide undergoing alpha decay, ano. So, next step is to find the change in mass for every 1 mole of radium-226 undergoing alpha decay. 1 mole of radium-226 nucleus undergoing alpha decay. So, mass ni siya, ang delta M class, is product minus reactants. So, the summation of the masses of all the products minus the summation of all the masses of the reactants. So, meaning, i-add nato ni siya ang radon-222 ug ang helium-4 minus ang massa radium-226. So, muna siyang 221.9703 plus 4.0015 minus ang mass sa radium 226. And we are able to get nga na ay change in mass nga 0.0053. So, nakita nato, diba nga, kung negative class, meaning product minus reactant pa ya. Products minus reactants. Delta M. So, kung negative ang answer, negative 0.0053 grams ang change per 1 mole of radium-226 nucleus nga mo undergo og decay, anong negative man? Asa may mas bugat ani kung na negative? Meaning, mas dako ang reactant. Okay? So, kung mas dako ang reactant, asa man ni padung ni siyang 0.0053 grams? So, di ba, conservation of matter, dapat dili siya mawala. Dapat kung unsay masa reactants, total mo siya dapat masa products. So, in this case, sa nuclear nga energy, sa nuclear chemistry, dili na siya mo follow. Nga naman, kay si mass, ma-convert man siya to energy. Mo nang gamit sa E equals mc squared. So, naay discrepancy, mas bugat ang reactant kumpara sa product, kayo pag-undergo ni radium-226 ug alpha decay, aside from producing these particles, naa na siya'y energy diha nga na-release. Kunya muna mo account ani niya. Ni 0.0053 grams nga nawala. Wala na siya nawala nga ni-evaporate lang na siya kalit. This has been converted to energy that's released in the process. So, muna itong gipangita nga kung 0.0053 grams ang nawala, ang change in mass sa kada 1 mole of radium-226 nga mo nucleus nga mo undergo alpha decay, pila may energy nga change kung 10.2 grams of radium-226. So, delta M, find the change in mass kung 10.2 grams na. So, pila di ay? So, and we have to express it in kilograms kaya mo may atong gamiton sa formula. So, this is just ratio and proportion. For every 10.2 grams of radium-226, ang 1 mole nga radium kay 226 grams nga radium, diba? Radium-226, good. And for every 1 mole of radium nga ni-undergo og alpha decay, na corresponding nga change nga 0.0053 grams nga radium. And, using your calculator, so you'll be able to get this in grams and then convert to kilograms. So, kada kuno 10.2 grams nga radium-226 na ay change in mass nga 2.4 times 10 to the negative 7. Na ay nawala nga 2.4 times 10 to the negative 7 kilograms nga mass nga na-convert to energy. So, kaning gamit nga mass, atong i-convert to energy. Unsay gamiton nga formula? E equals mc squared. So, muna na siyang step number 3. So, using the formula, delta E equals C squared delta M. So, i-substitute lang tong delta M. So, kani, and then this is C raised to the power of 2. We will be able to get 2.16 times 10 to the power of 10 joules. And take note nga na ay negative sign. So, mo-follow gihapon to atong convention sa exothermic o endothermic yung kato nga kuan nga kung mo-release o ma-absorb, di ba? So, because this is released in the process, negative na siya, meaning na-release sa process, you say 2.16 times 10 to the power of 10 joules of energy will be released when 10.2 grams of radium-226 nucleus undergoes alpha decay. Okay? Sige, another example. Sodium-24, which has an atomic mass of 23.991, decays by beta emission. So, gihatag diri ang atomic mass. You cannot find sodium-24 in the table, from the table. So, one of its uses is in the detection of leaks in water pipes. How much energy is given off by the decay of 10 grams of sodium-24? So, ang given na to, atomic mass sa sodium-24, which is 23.991, AMU, and then from the table we can find magnesium-24, 23.97845 AMU, and we have the mass of an electron kay beta 0.00055 AMU. And by the way, because it's beta emission, so sodium-24 man siya, before ta magtanaw ani, ato sa gitanaw ato sa gi-write ang equation, no, nuclear equation. So sodium 24 undergoing beta decay producing magnesium 24. Okay? So beta decay kanus agi tan siya mahitabo kung mas daghan og neutron or proton. So inyo na hinumduman ha. So next is, because this is atomic mass, we don't want atomic mass, we want nuclear mass. So ang atomic mass ni account na siya sa protons, sa electrons o sa neutrons. So atomic mass actually is kanang nay mass na siya total sa nucleus plus electrons. Yang atong tanawon kay nuclear mass raman, so aton ipangitaon. So kung atomic mass kay 23.991, that's equal to the mass of the nucleus plus the total mass of the electrons. But because this is sodium 24, 11 ni siya, neutral na siya nga atom, na 11 ka protons, meaning na po na siya 11 ka electrons. So muna siya diri, no? 11 plus 11 ka electrons. So the mass of the nucleus therefore is equal to the atomic mass of sodium 24 minus 11 times the mass of the each electron, and each electron has a mass of 0.00055 AMU. So ang nuclear mass di ay sa sodium 24 is 23.98495. Sunod, kay na naman kay mass ni sodium 24, then pareha gyapon natong sa previous nga number. So pangitaon ang change in mass for every 1 mole of sodium 24 nga ni undergo decay. So mass of the product, so mass of magnesium plus mass of the beta particle minus the nuclear mass of sodium 24. Ni-solve, makita na to nga negative gihapon siya, meaning na nawala. Meaning, pag undergo niya alpha beta decay, na ay na-release nga energy. So 0.00595 grams lost for every 1 mole of sodium 24 undergoing decay. So from there, kay ang given sa problem kay 10 grams man nga sodium 24. So ato na sa nasolvon. So kung na sa 10 grams nga sodium 24, ang mass sa sodium kay 24, dayon that's equivalent to 1 mole, and for every 1 mole of sodium 24 nga ni-undergo og decay, na ay corresponding ang 0.01455 grams. This is grams nga lost, no? And that's equivalent to 6.0625 times 10 to the negative 6 kilograms. And with this change in mass, ang iyang corresponding nga change in energy, just multiply it to the speed of light raised to the power of 2, and you'll be able to get 1.81875 times 10 to the power of 14 joules. And there is a negative sign indicating that it has been released. So gagmay kayo ang change, no, in the mass, pero dako kayo ang na-release nga energy. That's nuclear energy, class. It's really a huge amount of energy.